Alright, in this video we're going to go through some rational functions. We're going to look at their horizontal asymptotes, if they have one, and we're going to talk about graphing. So asymptotes, you should have already looked at vertical asymptotes before. Remember, those are going to be defined by their denominator. And remember, an asymptote is what happens with the graph as we approach infinity. Certainly for vertical ones, it's going to be, when y goes towards infinity or negative infinity. And so it's not necessarily what happens locally, meaning like right around the graph where we're between negative 10 and 10 on the x and y axis. Same thing is going to apply for the horizontal, and hopefully when we take a look at that, you'll see that. So when we get close to positive or negative infinity for the x values, our graph should be approaching the horizontal asymptote. It turns out your graph can actually cross a horizontal asymptote. There's nothing that says that it can't cross a horizontal asymptote, but it's going to still have that same behavior towards those the end points or end values. Graphing, that'll show up again. All right, so let's just dive in. I have some notes from last time being last year when we weren't all digitally learning. So I'm going to ignore some other things just to save us some time and go through there. All right, so let's get started here. All right, so let me try to zoom out a little bit. Our objective was to write the equation of a horizontal or oblique asymptote. Oblique would just be like our diagonal one of a rational function, okay? So there's another video on what a rational function is. Sorry, let me adjust the video again. So you're going to try to find the point of intersection between the graph and its horizontal asymptote as well. We might not get to that, but let's just dive in. So I put it in steps. There's really just two simple steps. The first thing is to look at the degree of the polynomial that's in the numerator and compare that to the degree of the denominator's degree. So up here in our example, we've got the numerator is 4x squared plus 2x minus 5. The only thing here that matters is the largest exponent. That's going to define my degree. So in my numerator, my degree is 2. And my denominator, the polynomial here, the degree is 4 because that's the biggest exponent. So we're going to basically compare 2 and 4 every single time you get a rational function when you're trying to find a horizontal or oblique asymptote. And we're going to focus on horizontal. So it's going to fit in one of three categories, 1, 2, or 3. All right. Either the degrees are going to be the same or they're going to be different. But really, when they're different, we compare. Is it less or more? So when the degree is less than the denominator's degree, as in this example over here and the one we just looked at, when the degree is less, the horizontal asymptote is y equals 0. So it's right along the x-axis. So if you had like y equals 5x to the third plus 2x minus 5 all over anything that has a bigger degree, like x to the fifth plus 17. I don't know. Just making up examples here, right? So this would also have a horizontal asymptote at y equals 0. Now it's important to know this is my answer. That is the horizontal asymptote, y equals 0. It's the equation. That's an equation. So we would never write 0. We would write the equation y equals 0 to represent that. Now, it's not always going to be the case where the degrees are different, and certainly not always the case where the degree is less in the numerator than the denominator. That's not always the case. Sometimes the degrees match, right? So if the degrees match, right, if they're equal to one another, then it's defined by the leading coefficient divided by the other leading coefficient. So the leading coefficient is that first term's coefficient. So when it's written out in standard form like this, 4x to the fifth minus 8x squared minus 15 all over 3x to the fifth plus 5x minus 9, we know the degrees match. Both of the degrees here are 5. And so we just look at this 4 over 3. 4/3 is going to be the equation of our horizontal asymptote. Okay? If we wanted to create another example, if I want to make an example problem, let's just use r of x. We use this often. We want the degrees to match. If the degrees match, and I'm going to write it in a different way. I'm going to write it like this. Oops. I'm going to write it in factored form. right now the degrees don't match because I have 1, 2, 3 factors that would have an x to the third power. So let me just make that work. All right, cool. So now they both would have they would be a third degree polynomial. How would I get how would I look at the coefficients? Well, right now the leading coefficient would be 1 for each one of them. Right? If I multiplied all that out, I'd have an x to the third power, and so it'd be 1x to the third power. If I put like a 10 here, well, now the leading coefficient is 10. So this would be 10 over 1. Right? The leading coefficient in the denominator would be 1. What if I made that 5? So my horizontal asymptote would be y equals 10 over 5, which is 2. Okay? And that's all that it would do. We're going to ignore the case where it is an oblique asymptote, just due to time. And so I'm going to just jump over to the back. Okay? There's some other examples on this practice. You can get practice in other areas. In this example, I think we're going to end up skipping this just due to time, but it is important to know that a horizontal asymptote can cross the graph. Okay, here is a quick example. We've got the horizontal asymptote would be y equals 2 because our degrees match. It's 2 over 1. And what we would do for this, and I'll let you solve this if you have the time, we would look at the solution to this equation. We would look at what x value would cause this to be true. Man, I am not writing correctly today. We would solve that for x, okay? And we would potentially get an answer. And if we got an answer, that x value would certainly match with a y value of 2, and that would be the point of intersection. So POI for short, point of intersection between the horizontal asymptote and the graph. Now you can't do that with a vertical asymptote because remember the vertical asymptotes are equations that show where it's outside the domain of the function, right? But there's nothing about 2, the y equals value, that means that it's not outside the domain or anything like that. All right, so last example, we're going to try to put all of this information together. There's been some other videos on finding x-intercepts, y-intercepts, vertical asymptotes. We just looked at horizontal. There isn't an oblique, and I'm going to omit that for now. And then there's this point of intersection thing. So I think I'd either give you this or omit this piece, but it is important for you to know, hey, there is a possibility where a horizontal asymptote can cross the graph. It's the vertical ones that can't. Okay, and you probably didn't learn about horizontal ones, and you may have even been told asymptotes can't cross the graph, and that's true for vertical, not necessarily for oblique or horizontal. Okay? All right, so let's try to make a graph of this. And so I'm going to start off by just drawing my x-axis here. And I'm going to try to use up all of this space. And so if you were using your notebook, you'd want to definitely use up a lot of space. Before I just start drawing my y-axis and putting everything on there, I should probably take a peek at what I'm about to graph. So I'm going to put the x-intercepts on there, the y-intercepts, and all of this relates to this equation right here. I've already done all the work for you. So I've got x-intercepts, y-intercepts, vertical asymptotes, horizontal asymptotes, and a point of intersection. And then I'll have to make a guess about what the graph would look like. It's just a sketch. One note, when I look at these numbers, none of them are very big. So when I do scale this, I'm going to be really careful about that. I'm going to try to be very careful. Now your graph, you don't have to have the best handwriting, you don't even have to use a ruler. But you should try to take your time and give yourself enough space here. So I've got vertical asymptotes and x-intercepts again that they're pretty small values. They're not going to like all the way out to 10. So when I count, I'm going to count by ones, but I'm probably going to put like 1 right there and 2 here and 3 there because I'm definitely not going to go past 3. So this is 1, 2, 3, and I'm going to do the same thing on the negative 2. 3, negative 3, negative 2, negative 1. And then the y-axis is very similar. It doesn't look like I go past 4/3 on the y-axis, so I'm going to leave that one there. 1, 2, negative 1. And you try to make your spacing about the same as what you would, you know, x and y. You try to, if it works. Sometimes it doesn't always work. All right, so let's see, x-intercepts. I have 2 places where that crosses the x-axis. So negative 3/2, that's negative 1.5. So there's 1, and I'm going to put a dot there. And then 1/2, it's me right here, and I'm going to be really clear about that dot. I'm going to make it a solid dot so it's very easy to see, because I know I want my graph to cross over the x-axis there and nowhere else. So I don't want to cross the x-axis anywhere else but right here. Okay, otherwise it would be listed there. My y-intercept is at 0 3/4, so that's going to be approximately right here. Same idea. I better not cross the y-axis anywhere else but right there. Okay. My vertical asymptote is at -2/3. X equals -2/3 would be about right here, and it's just a vertical dotted line is how we represent that. And our graph is going to approach this towards positive infinity and negative infinity. One of the two or both. Could be like that or one or the other. Over at 2. Okay, so we're starting to construct all the features here. And then 4/3 is our horizontal asymptote. Again, it's going to be a dotted line, so that's 1 1/3. So 1 1/3 would be approximately right here. Alright, so you can't cross the vertical lines, but you could cross the horizontal one. And it looks like the horizontal one has a point of intersection at -1/4, comma 4/3. So where would -1/4, -0.25, 4/3 would be about right there. Okay, and it looks like that's all the information that I know about the graph. So I know these 3 points are here. And so from here on out, you're essentially, I mean, obviously you could use a graphing, like you could use Desmos and plug it in and you would know. But if you were to do this without, which in the years past we've had to, you would have to make a bit of a guess about what would happen, but it is grounded in some of the concepts. So like what would have to happen, we're crossing the horizontal asymptote, where can this continue on? Can it go back this way? No, it can't. One reason would be because it would fail the vertical line test and make it not a function anymore. Plus, I've got this vertical asymptote right here, and I know my graph needs to approach that towards positive infinity or negative infinity. So on this side, it looks like it's going to approach towards positive infinity. Now, let's work at the rest of this portion. Remember, from here, I can only cross the x-axis right here. I can't cross anywhere else. It's definitely not going to pop back up and go this way, because if it did, I'd have another point of intersection there with the graph and the horizontal asymptote, which I know I don't have. And so the only option right here is to go down here, and I have to show that it's going towards this negative infinity for this vertical asymptote. So my graph should show that it's getting closer and closer and closer to this dotted line, that vertical asymptote. So that's the middle section, and I notice a lot of students will do that and then they're stopped. But remember, our vertical asymptotes are very closely connected to our domain. So we've got 2 other sections here on this left side and the right side where we still have to make our guess. Now you've got 2 options here. I know I need to get closer and closer to this dotted line, and I need to get closer and closer to this dotted line. So I could make a guess here, but that's not using all the information that I have. I have this x-intercept, so I know it's going to have to look something like this, where it gets closer and closer to that dotted line there, and like that. And that is actually a correct guess for this one. Okay, so it crosses where I said it would cross. The same idea will happen here. Now I can't just do this. I can't make a guess that way, because that would make it cross the x-axis, and I don't have that information. So my only option is to do this. There's a little section over here where it gets closer and closer to that vertical asymptote and closer to this horizontal asymptote. And that's kind of how you put the guess together. This kind of idea might become obsolete in the future, given we have so many graphing devices with us. But that is putting all the information together. It's more likely that you would have to then take a graph and write an equation. So I'll have to make another video about that. I hope that helped, though.